everyone, hope you are doing well. Welcome to another problem solving session. This problem solving sessions is for those aspirants who want to take an exam seriously, and so we will be picking up problems from different mathematics examinations and we'll be solving them here so that you have an exposure to the higher mathematics and to the also what type of questions you are going to expect in the exam. So here we are going to start a new series, that is the Isi M.Math series. So in this session we will be just picking up the questions from M.Math ISI. So as you all know, and those who don't know, Indian Statistical Institute, one of the most prestigious institute, offers a celebrated course in Masters of Mathematics where people can apply through an examination. So after the examination they need to appear for an interview. So you can understand very well the level of mathematics being taught at such a prestigious institute, such an old institute, reputed one. So for that, the pattern of the examination is quite simple. You have two parts, the objective part and the subjective part. So you need to qualify in both the parts so that you can get a call for the interview, and then after getting the interview call you need to clear the interview also. So today we are here with 2019 M.Math question, and so the first question is written on the board. It says let S be the set 1, 2. So this set 1, 2 is a subset of R. It's given. Now we need to consider the function f with domain R and codomain R given by fx equals infimum of x minus y, where y is from this set S. So y is from this set S. What does it mean? It means essentially that y is either 1 or 2. So then if option A, f is not continuous, f is continuous but not differentiable at 1, f is continuous but not differentiable at 1 and 2, f is continuous but not differentiable at 1, 3 by 2 to 2. So I request everyone to just try this problem on your own. Okay, so the stipulated time that was meant for this question is over, and now I am going to solve this question. Now, I just want you to just consider on this, just have a focus on this function that I am keeping on the board. So it says infimum of mod x minus y, where y belongs to x. And now to approach such kind of questions, I always recommend everyone that please do try and draw the graph. Okay. So how many can we have here? The graph of x minus 1, mod of x minus 1, and the graph of mod of x minus 2. Okay? So what is the graph of the mod x minus 1? So this is my 1, that is the vertex point, and this is the graph of x minus 1. And what is the graph of mod of x minus 2? So this is point 2. So this is point 2, and this is the graph of x minus 2. Just remember one thing, that these two lines here are parallel, because the parallelity might not be observed here because this graph is not to scale. But remember that in examination, when you are just appearing for these types of questions, when you are facing these types of questions, I always recommend you to draw the graphs. This is because graphs makes a lot of things clear. So now you see that we have considered the function. So this basically is the function. This whole set is the function. So this totally is the function. Now in which points they are non-differentiable? We can easily see that it is non-differentiable in 1, it is non-differentiable in 2. Now how do we recognize non-differentiability in graph? So when you draw a graph of a function, you will notice pointed edges like this. So see this edge is pointed, this edge is pointed, this edge is pointed. Sharp edges is not a differentiable graph. So you might have heard about a famous thing that differentiable curves are also known as smooth curves. So whenever you see an unsmoothness in the graph, you will just point that that's the non-differentiability point, and this is the point of non-differentiability. So in this graph we have just 3 points of non-differentiability, and what are these points? These points are 1, 2, and what could be this point? You can do this in 2 ways. Either you just solve this equation directly, you can get it, or by graph what can you say? Using common sense and by geometry you can say that this perpendicular is just the midpoint of this. Why? This is because you see that x to the middle point and 2 to the middle point is basically an isosceles triangle here. And for isosceles triangle, the vertex of the equal sides, when the perpendicular from that is drawn to the base, it bisects the base. And so this is going to be the midpoint. And what is the midpoint in 1 and 2? That is 3 by 2. So the points of differentiability is 1, 3 by 2 and 2. Okay, and what question does this correspond to? To what option? It corresponds to option D. And hence D is your correct answer. So what did we basically learn from this question? This question was very straightforward question in a manner that I must say that this question was a little tough if you just tried it in the simple calculus way or the monotonic calculus way. But this problem became more simple when you try to visualize the graph. So whenever we are doing mathematics, we need to visualize an object first, right? So visualization for mathematics is very much important, and graphs and figures helps us to visualize. This is because the entire visualization of the mathematics lies in the symmetry. So I must say that for visualization of functions, you need to have a proper knowledge of graph. Now remember that all the questions are not solvable by graphs. This is because what the graphs we are drawing is not to scale. But of course, in questions like this, which require tricks and doing fast, you can always consider the graphs of these functions to just know what are the points of continuity, what are the points of non-differentiability, etc. But remember that we do not analyze a function on basis of their graphs. We try to draw a graph on the basis of their functions. And when complex functions are involved, so what happens when complex functions are involved? When complex functions are involved, we try to break it into smaller, easier functions, and we try to draw the graphs separately to the scale, so that we can just analyze the complex functions in terms of the smaller known functions as graphs. Okay, so the functions that were present here are mod of x minus 1 and mod of x minus 2. They are in the sense not the simple function of mod x that we are considering. So I used my knowledge of the graph of mod x to draw these two graphs, and then we could conclude the answer very easily. Okay, so practice graphs and try to see graphs as more as possible. I recommend you an app which is named as Desmos. Many of you have probably heard of that. So in Desmos, try to just visualize various kind of graphs. Okay, that will help you increase your sustainability, increase your visualization power. And visualization and imagination are very important for mathematics. So now we get into the second question for the day. Question. Okay, so here is the second question. It says that let f from R to R be a twice differentiable function with f double dash x, that is the second derivative of x, greater than 0 for all x in real numbers, then fx equals to 0, option A, has exactly one solution. Fx equals to 0 has a positive solution if f0 equals to 0 and f dash 0 equals to 0. Has no positive solution if f of 0 equals to 0 and f dash 0 greater than 0. Fx equals to 0 has no positive solution if f of 0 is 0 and f dash 0 is 0. So I give you some time to try this question on your own. Okay, so the stipulated time that was meant for this question is over. So now we have to get back to our old friend. So that friend is the graph. So we need to try to draw a graph of fx just visualizing the conditions. Okay. So I'm not rubbing the options here. Okay. This is the most important information that is given in the question. This is the most important information that is given in the question. Why? If double dash x greater than equals to 0 for all x, what does it mean? What does it mean for a derivative of a function to be positive always? Yes, if in a differentiable function, if a derivative is always positive, then f dash x is increasing. So when I say this, that from this, what I can conclude from this, I can conclude that f dash x is increasing, and this fact will help us in all the questions that we do. Okay, so f dash x is increasing, that is what will help us. Now the first solution says, the first option, fx equals to 0 has exactly two solutions. Okay, so let us draw a graph of fx where f dash is increasing. So we are trying to draw a graph such that f dash is, say, increasing like this. So this is basically the graph of the slopes. So let me just shift it a bit upwards. Okay. So why I am eliminating option A on basis of graph? So let us assume that fx has two solutions. Okay. So let us assume that fx has two solutions. So let this be the arbitrary graph of fx, and we have considered that fx has two solutions like this. Okay. Now let us analyze the point near x1, and let us analyze the point near x2. Okay, so if we analyze these points, what we get is basically, we just visualize the slope at point x1. Okay, so what we do, so the pen in here, so we just visualize the slope at these points, and we visualize the slope at these points. This is the slope. Now, if it has two solutions, you can see that the slopes near x1 is increasing. You can very clearly see that the slopes near x1 is increasing, which means that f dash x is increasing near x1, isn't it? So you see that these slopes are increasing in nature as I have drawn the graph. Now what about the slopes near x2? We can clearly see from the graph that x2, at point x2, these slopes are decreasing as I have drawn. So the straight lines in that graph are the slopes. So these slopes are decreasing. Now what does it say? Why I did reject it as a solution? Remember that in the question it was given f double dash x is greater than 0, and from there we have concluded that f dash x is greater than 0, or f dash x is increasing, not greater than 0, f dash x is increasing. But we have found certain intervals near x2 in the neighborhood of x2. So I am introducing the neighborhood property here. So in the neighborhood of x2, we have found such points that is mapping to fx such that f dash x is decreasing. But f dash x cannot decrease, therefore option A is wrong. Now let's look at option B. So what does option B say? Option B says that fx has a positive solution if f of 0 equals to 0, fx equals to 0 has a positive solution if f of 0 equals to 0 and f dash 0 equals to 0. Okay, so you can clearly again see that this cannot happen. Why? By the same method. Try to draw a graph. So if at 0, if the derivative of fx is 0, then how will the graph look like? The graph will look like this. At 0, this line will be the tangent, or the tangent will be parallel. So since f of 0 is 0, it is given. So the tangent here will be the x-axis itself. And now we know that f dash x is increasing. So if there is another root, then in the neighborhood of this root, we can find the slopes. Similarly, by the previous logic, that f dash x will be decreasing, but that cannot happen, and therefore option B is rejected. Now let's see option D. So if x equals to 0 has a positive solution. So it says that if x equals to 0 has a positive solution if f dash x. So f of 0 is 0, that is given here, and it says that it happens only if f dash 0 is less than 0. So what does f dash 0 less than 0 means? At point 0, this f dash fx is decreasing. So again, let us assume that it has a positive solution at x1. So let x1 be the positive number where it has the solution. Okay? Now we see that f dash 0 is less than 0, and therefore the function here is decreasing. But we know that the function f dash cannot decrease. This is because double dash is already greater than 0. And therefore on the basis of that, option D is rejected, and the correct answer to the question is option C. Okay? So the correct answer to the question is option C. Now, in this video, what we have explored is that amazing and fascinating properties of graphs. So, I will say that keep on practicing the such questions with helps of graphs, because they are very useful for a proper knowledge and for a proper understanding of such questions and how to solve. Saurav Sir's classes provides a wide range of exquisite study materials with overwhelming packages that will help you to build up your confidence and clear such exams. So I strongly recommend all the serious aspirants of Isi M.Math to get a copy of those study materials. And again, one of the fundamental things that you need to remember is that a graph is analyzed from the function. So when you know information about the function, then only you can draw the graph. It is not that by drawing the graph you get information about the function. So here I got information about the function first, about double derivative, about the increasing, decreasing part, and then I could draw the graph. So if you don't have a prior information of the functions, don't attempt to draw the graph, as that will be really very wrong. So all the best for your exams. Hope you will excel in all the streams that you are working on. Best of luck, goodbye, and stay well. Thank you.